Welcome to Sairam Tribuli YouTube channel. Let us discuss Module 4 Renewable Energy Sources and Storage. Name itself indicates we are going to discuss renewable energy sources like wind, solar, fuel cells, hydro power plants, and bio chemicals or biogas or bio fuels, right? So, renewable energy sources, sustainable energy options for the smart grid. See, a smart grid, if you want to make a smart, like whatever generation, we have to add green energies like solar, wind, bio fuels or whatever. So next, penetration of variability issues associated with sustainable energy technology. So we are adding some of the energy sources over here like wind and solar into the main generating station. Demand response issues, so and electric vehicles, plug-in electric vehicles, and PHEV technology, environmental implication, storage technologies, and tax credits we are going to discuss. And interoperability inside the system, and the standards, cyber security, introduction to interoperability standards, and smart grid, cyber security and possible operations for improving the methodology for other users. So these are the concepts we are going to discuss now. One by one we will discuss. First one is sustainable energy options for the smart grid. So sustainable energy options in a sense like friendly, like environmental friendly, sun, wind, hydro, biomass, and geothermal, right? So sustainable energy is derived from the natural sources. Renewable resources are coming from the natural resources, right? So and sometimes called as a green power energies because they are considered as a environmentally friendly. So everybody knows, right? So the renewable energy sources doesn't pollute the nature, right? So next we have a remote utilization storage, REA resources output, enhancement of functionality, grid connection to renewable energy systems, facilitating the give and take of energy from the system, redistribution, reallocation of unused power from the grid connected RES, facilitating the storage of grid generated and REA generated energy by backup storage technologies at the customer end, tracking interactions for a billing and study, enhancement of functionality of electrical vehicle, plug-in hybrid utilization of vehicles, battery packs, energy storage devices. So in that we are having number of energy resources like solar, wind, thermal, geothermal, and hydel. So I just considered solar energy. Solar energy harnessed by the use of photovoltaic cells. So number of cells will be there, and then it forms as arrays, and arrays forms as a um, module, and so whatever the sun radiation hits into the solar panel, what happens, there is a recombination of p side, and then p type electrons and then n type electrons collide each other, and protons and then electrons recombination take place, so it gives output like a battery operation. Okay, in 1839 the French physicist Edmund Becquerel introduced solar energy. So penetration penetration and variability issues associated with the sustainable energy technology. The degree of penetration by sustainable energy into the today's grid versus by the location, depending on the availability of the conditions necessary for the viability and utilities. So demand response issues. Energy management involves controlling electrical and mechanical system to reduce power needs, and associated with the cost, DR helps to reduce the customer demand on the grid. So that is dependent on the demand, right? So if suppose demand response is also one major constraint in the smart grid technology, because there is a, if suppose the person needs some more amount of energy, more amount of electricity or whatever, so response issues will be there. And climate change also affect to the renewable resources, because whatever the renewable energy sources we are extracting from the nature, or extracting from the environment, universally available, right? So it affects the climate changes. Climate changes in the terms commonly linked to the issue of global warming, cooling, resulting from the increased emission of greenhouse gases. The term climate change refers to an distinct change in the measure of climate lasting for the long period of time. That is, major changes in the temperature, rainfall, snow, wind patterns lasting for decades or for longer. So next there is a storage technologies. Energy storage is important to utility loads. So in the renewable energy sources, a major drawback is storage. Uh, it will take time, right? Storing the whatever the electrical power supply and electrical vehicle solar energy system, uninterrupted power supply and energy systems, remote locations. Energy storage has always been closely associated with solar installations, include solar heating and PV cells. So as you can see the diagram over here, there is a photovoltaic PV options, wind power plants, and then charge controller. Charge controller is present, switching logic, and there is a diesel power option because of backup, and the storage option, battery bank will be there, super capacitor will be there, AC to DC, DC to AC power inverters, circuit breaker, AC bus, and switch fuse will be there. These are all the loads you can consider. Right. So just see here, there is a solar power and then wind power plant will be there too, from the power stations. It's coming from the like a generating station to the here, and charge control is must because to control the charge variations will be there, right? It depends upon the nature also. So controller is needed, and then DC bus because DC is generating, right? So DC is needed, and bus bar is needed. And if you want to convert into AC inverters, I mean like here there is a AC bus, we are having inverters for converting DC to AC. For example, in our college we have a solar power plant with a 212 kilowatts, so there we are not having charging technology, but here we have a charging technology, I mean charging storage is possible. Here see, DC we can store but AC cannot store, right? So here from the DC bus we can store storage option, battery bank, and then super capacitor, right? Next there is a AC, directly we can use from the um, supplier, I mean bus, AC bus. Even though they are having DC power, diesel power options because of backup purpose. Circuit breaker will be there, but to break the circuit when fault occurs, when abnormal condition occurs, switches and fuse will be there. So switch is for on and off conditions. Load 1, load 2, load 3 are the outputs, right? I think you understood this concept, because a very easiest concept to understand. Renewable energy sources will be there, battery backup will be there, and then battery will be there, storage will be there, and inverter will be there, and also AC conversion will be there. So this is the overall concept. So let's have a next, we'll discuss tax credits, right? Tax credits is our example of incentives to promote customer buy and in and up participation in the utilization of RER and practice of energy efficiency. The DOE offers the number of tax credits to the consumers, right? This is the concept uh, we discussed here. So in this tax credits, it's a like a I mean like it depends upon customers view also, right? So this is the overall concept of renewable energy sources, and once again revise, right? See, in this module, in this module 4, we have very easiest concepts like renewable energy sources and then storage technology, and also we have here hybrid vehicles also will be there. Hybrid vehicles already we discussed in the earlier videos. Uh, so just you concentrate on renewable energy sources, and after that you concentrate on storage of battery. Storage of battery, everybody knows, like from the uh, like batteries, I mean DC we are storing. This is the overall concept of this, right? So just I'll wind up. Okay, okay.